Hello, everybody. My name is Marc Thuillard. I am a physicist specialized in data analytics and artificial intelligence. And I've applied data analytics to database on myths and Skylores, which are a version of myths and folk tales dedicated to the stars and to the sky. Let's start. Are two types of approach to mythology. There's a classical approach. Think of the Greek mythology. You study the different characters. You try to understand how they behave. You start to understand also how the mythology is embedded into the society. It's quite interesting. The second classical approach that I'd like to present here, which is you start from motifs. A motif is a small unit making sense by itself. And motifs have the tendencies to repeat themselves in many stories in the world. Therefore, they are very interesting. As an example, I will discuss the story of the man on the moon, which is found everywhere. You find it in Africa, you find it in Eurasia, you find it in America. You know, if you look at the moon, full moon, you see some structure, and this structure inspires people to see a man, an animal, maybe a tree on the moon, and it triggers stories, and these stories are widespread in the world. The second example I'd like to give you is the analysis of probably the largest database on myth and folktale in the world, the one from Yuri Bereskin, and it's a very large database. I'd like to show you what can be extracted using data analytics from this database. Let's start with the man on the moon. More precisely, I'd like to introduce three different versions of this story, which is widespread in different regions of the world. It's the water carrier, the frog or the toad on the moon, and the rabbit or hare on the moon. I won't distinguish anymore between rabbit and hare, frog and toad. I speak about rabbit and frog. In dark blue, you see instances of the rabbit on the moon that you find in some tradition. You see that you have tradition in Africa, in India, you go up to China, and there you see a first transition. You see a transition between a story about a rabbit on the moon to a frog on the moon, and they cohabitate. They are found first in the same stories. If you go further north, you see a second transition between stories in light blue about the frog to stories about the water carrier on the moon. And the water carrier is often a young lady carrying a water pail. If you look also at these stories, what do they tell you? It's quite interesting because they are related but different. Let's start in Africa. A story in Africa about the rabbit on the moon tell about the moon who gives the order to the rabbit to go to man and tell him that man is immortal. The rabbit corrupts the message on the way and tell man, hey, you are mortal. And the reason why men are mortal nowadays. In India, it's a different story. It's about a rabbit self-sacrificing himself to serve as food. So it's not about purely death, it's really self-sacrifice. If you go to China, then it's related to the famous story of Chang'e, and it's about the elixir of life. It's about immortal life. So you see this transition from pure death, self-sacrifice in India, to immortal life in China. They are related topic. And even if you go to Mesoamerica, you see also that there are stories about the rabbit on the moon there. And the story is the following. You have two gods, and they got order to jump into a fire, to self-sacrifice themselves. And one is very courageous, jump into the fire, and becomes the sun. The other one is not so courageous, at the end jump into the fire, but is regarded as coward. As a punishment, he becomes the moon and gets smashed in the face by a rabbit. Now, if you go further up, you see a second transition. You see a transition between the frog, the toad on the moon, heavily related also to water, to the water carrier on the moon. So you see a second transition, but with related topic. And those stories go up to Eurasia. If you look at these stories, they are really old. We can't say how old they are, but the first historical mention of these stories are in China and are from the 2nd and 3rd century BC, so a long time ago. On the right, you see a famous banner found in a tomb from the 2nd century, and the banner is covered with mythological motifs. And on the top left, you see a crescent, a moon crescent. I got it enlarged on the left with a frog inside and a little rabbit. And we're almost sure that it's about the story on the moon because already 1 century before you had the story of Chang'e on the moon that was recorded, written on some bamboo slip. The water carrier on the moon got also recorded, but much later. The first mention is in the Poetic Edda. It's a saga from Iceland written on the 10th century, but relating about the much older mythology of there. And also in Shakespeare, mentioning the water carrier on the moon in one of his plays. You find it also in some rhymes in children's song in England. So basically, it crosses time, it crosses space over several millennia, and it gives some really much depth to these stories that you also find in North America among the first mention of myths that got recorded by European. Now let's go to the second part on data analytics in mythology. And I've started by analyzing the whole database from Eurybereskin with 2,200 different motifs and with the absence coded in 900 tradition. So it's coded, it's like a big matrix with 0 if the motif is absent in this tradition and 1 if it's present. And so you can use data analytics on this matrix. I've analyzed 2 subsets also of this big data. One subset related to the sky. You know, it can be very broad motifs like on thunder, on the cloud, how you get to the cloud, how you get to the sky, if you have a ladder, about the moon, about the sun. And a second subset, a smaller, even smaller subset of star-related motifs. It's more specific here. It's about Orion, about the Pleiades, Milky Way. So you exclude here all the sun and moon motifs. I don't have time to go very deep into the data analytical methods that I've used. I use basically a combination of phylogenetic network and a contradiction analysis to classify the different motifs. And for the star motifs where classification was not possible, use an areal distribution network. I've just published the second edition of my book on wavelet and soft computing, and these methods are described in the book, so please refer to it if you want to get some more information. Let's concentrate on the result. What we see is that you have two layers of myth in the world overlapping, but being predominant in one region. So in blue, you have the first layer of motifs that are predominant in Eurasia and the northern part of Northern America. In red, you have the motifs that are predominant in South America, the southern part of North America, and a region in Southeast Asia and center on New Guinea. What is interesting, the topics in the motifs are also different. In the first layer, the blue one, there are many motifs about woman, about man. In the second layer, the red one, you have many motifs about the sun and the moon. And it brings us again to the sky. If you look at the first layer, for instance, you see that this layer appears everywhere, and a cluster analysis shows cluster in the different regions. You see the cluster 1, 2, 3 in Eurasia. You see clusters, also many clusters in America. And there are two clusters that are especially interesting because you find them on two continents. The number 6 in the eastern part of Eurasia and North America, the circumpolar part. And the second one, which is more puzzling, which is the cluster number 5 that you see here, covering South America and the region around Papua New Guinea. And that's very strange. There's another way of looking at it is what I call a matching algorithm. You start with some region. The region here on the red in Amazonia Mato Grosso region. And you look at the motifs there and you see why do you find the same motifs in the world. And you see that the motifs found there are quite widespread around the Pacific, going down to Australia, to New Guinea. So it seems that there's really a relationship between the motifs in South America and the one in New Guinea. What could be the reason for it? Because they're so far away and there was not much contact between those two regions. So you can repeat the matching approach by selecting just motifs related to gender, because maybe it's a relation to gender that makes them having some commonalities. And if you analyze the gender-related motifs, you really find also around the Pacific some connection. There's also a second connection that we find with many motifs related to a transformation. You know, a transformation from a man to an animal, from a bird to a man, and so on. And if you take transformation as linguistic marker, you find also similarities between the distribution around the Pacific. So there are at least two possible here explanations. They have comparable ontologies, or they have similar relationship to gender. But I must also add one last possibility. You know, ancient DNA has shown that several tribes in South America have DNA that is very comparable to the one that you find in Australia, in the New Guinea region. And that is DNA is shared DNA is very ancient and most likely mean that they share some society, some common ancestor. So migration is also and diffusion also a possible explanation beyond similar ontologies and gender relationship. Now you can do the same analysis on sky-related motifs. You select the motifs related to the sky and you see basically the same picture. These two regions. There are some difference, like the sky-related motifs in Africa are more related to South America and New Guinea. And also in some region, you don't have too much data and you don't get too many data that got validated. Because it's very important that our classification method can be validated. There are methods described again in the book to know if the result we're getting makes sense and can be validated. Now, if you look at the motifs, at the sky motifs in America, and you find through matching that they match mostly to motifs in Eurasia. If you look now at sky-related motifs in South America and New Guinea, you see that they are still close, but now they are in two different clusters. Cluster number 9, red, and cluster number 10. So on one hand, you see a similar distribution of the motifs between sky-related motifs and whole motifs, but a difference for sky-related motifs between South America and the region around Australia, New Guinea. But what is very important is that the general feature of these motifs are the same. They have the same type of distribution. You find them in the same place. So what does it tell us? It tells us that if you study sky-related motifs, you can get more information by looking also at the motifs that are important in the same region. Because sky-related motifs are not a mythology which is completely independent of all other motifs. They form a unity. And I think it's the main message of this presentation and the main result. Now, if you relate to the star related, you go to the star related motifs, then things become difficult. It's difficult on one hand because you don't have that many motifs, and that also because you have many motifs that are in Eurasia. You have also quite many motifs in America, but less. So you don't have this homogeneity that you have for sky-related motifs. And so the classification didn't get any result that got validated by the method. So we had to use a different method, which is a areal distribution. Basically, we look at motifs that overlap. And if the overlap is large enough, we relate them with an edge. And you see here small network or sub-network of motifs relating each other. And it's interesting because if you go in the red motifs, you see that in some region you have several motifs that overlap. The Pleiades might be a sieve for grain, but also might be opening. So it's not only one meaning for the stars and the constellation. They can be embedded in different stories. Now, we found these 4 different clusters, and you can see where are they geographically. And you see that on one hand, they define a geographic region, but they all intersect here in a region between, I would say, the Baltic Sea and the Eastern Mediterranean Sea. But they spread all over Eurasia. You can repeat this in America, um, but the picture is not as nice because you don't have so many motives. In East Africa, get a little bit, and West Africa, you see also some networks. So you see this network in America. You see that the Iades are important, the Milky Way, the Tapir is important, Ursa Major. So you don't have that many overlap. You don't have so many constellations. You don't have so many stars that are similar to the one you find in Eurasia, and that makes the study more difficult. So I'd like to conclude with open challenge. I think the star-related database should be completed. There are not enough data for Oceania and part of Africa, and I think should be completed. The second challenge is um, very often you have report that tell about Orion, but if you go deeper, you find that there are constellations or stars that are near Orion and have different name, have also different stories. And that make it difficult. How do you compare the constellation and the stars in a different context where they might have a different name, they might cover slightly different part of the sky. But there is also another challenge is making people work together. You have cultural astronomy. And in cultural astronomy, you have many people working in archaeoastronomy. So the connection between archaeology and ethnoastronomy and astronomy. You have, on the other hand, people working on astronomy, ethnoastronomy, and mythologies, folk tales. And here, cosmogonies are important. And I think what would be really nice is connect cosmogonies to archaeoastronomy. It's already done for some tradition, like the Inca tradition. And when you do it, you get very, very interesting result because you can embed the result on archaeoastronomy in cosmogonies. And that makes it really exciting. I'd like to conclude here, and I thank you for your attention.